Now we're going to do exercise consolidation exercises question B. The question says solve for x. Okay, I'm gonna write here B1. We have like 4 to the power of x equal to 0.25. Now, what can we do here? I prefer to write 4 in terms of its prime factors. Okay, and then 0.25 can also be transformed into a fraction. Okay, most people know that this is a quarter. And then if I write 4 in terms of the prime factor, it's going to be like 2 squared. Then we're going to, over here, we know we times the exponents. Okay, so that makes 2 to the power of 2x equal to a quarter. But a quarter can be written as also 2 to the power of 2. Okay, in terms of its prime factor. 2 to the power of 2. Then this can be written as 2 to the power of x equal to 2 to the power of 2 can be written as 2 to the negative 2. Now that we have a common base, okay, common basis, we can just drop the basis here. When we have common basis in the equation like that, we drop the basis because remember that law of exponent that says if we have like a to the m equal to a to the n, this implies that m equal n. Okay, so we're going to drop the basis and then equate the exponent. So that means x equal to negative 2. And then question 2, we have like 9 multiplied by 27 to the x minus 2 equal 3. So in this case, we do the same. Okay, we're going to write each. We're going to write 9 in terms of its prime factors, and then 27 also in terms of its prime factors, and then equal to 3. 3 is already a prime number, so we leave it like that. 9 in terms of prime factors is going to be 3 squared. 27 is 3 to the power of 3. Okay, so this means we can write like 3 squared multiplied by 3. Here we times the exponents, and remember we're going to do 3 times x minus 2. It's going to be like to the power of 3 times x minus 2, like that, equal to 3. Now the fact that we have this, it means we can just do the fact that we have a common basis. We can just add the exponent at the denominator there. Okay, so what am I saying? The fact that we have a common basis here, 3 and 3, that we can add the exponents at the exponents, not at the denominator, but just exponents. So this will be 2 plus, okay, we do 3 times x, that makes 3x, and then 3 times negative 2, that makes negative 6 equal to 3 there. And then this means 3 to the power of what? Of 3x minus 4. Okay, because 2 minus 6 means minus 4 equal to 3 there. Now that you have like common basis, we can just drop the basis. Okay, and then equate the exponent. That means there's an invisible exponent there of 1. So that means 3x minus 4 is equal to 1. Now we can move the negative 4 over. That makes 1 plus 4. That means 3x equal to 5. That means x, if we divide both sides by 3, x will be equal to 5 over 3. Okay, we divide by 3 there, by 3 there also. Let's simplify. We have x is equal to 3. That was question 2. And then we can also do a question. Okay, let's do question 3. I'll write it over here. Question 3 was given by 16 times 4 to the power of x plus 3 equal to 8 to the power of x minus 2. Then we can reduce, okay, all these numbers in terms of the prime factors. So 16, I'll write in terms of prime factors. Okay, 4 in terms of its prime factors. 8 also in terms of its prime factors. Now 16 can be written as 2 to the power of 4. 4 can be written as 2 to the power of 2, and then 8 2 to the power of 3. Then this will make what 2 to the power of 4 multiplied by 2 to the power of 2 open bracket x plus 3. Okay, we times exponents here. And then there also shall be 2 3x minus 2. We times exponent also. Then over here we'll add the exponent. So this will make like 2 to the power of 4 plus 2x plus 3. And then there 2 to the power of 3x minus 2. Then what we do, we can just drop these bases and then equate the exponents. That means it's going to be like 4 plus 2x plus 6. So here we times this with that, and that with that, this with that, and that with that. So that makes equal to 3x minus 6. Then we need to group all the x's one side. Okay, so this will be what? We can move 2x over there and then move the negative 6 on the other side. So we have like 4 plus 6 plus 6, because negative 6 moves over becomes positive 6, and then 3x minus 2x. Okay, and then we can simplify. So that makes 16 equal to x, okay, or x equal to 16. So that's question 3. Okay. Now we can do question 4. Well, question 4 is given by 2x to the power of 3 over 2, okay, equal to 250. So in cases like this, 2 is a prime number. We can first divide here by 2 and divide there also by 2. Okay, and then we get like x is equal to 3 to the power of 2 equal to 125. 125 is not a prime number, so we can write in terms of its prime factors. So this will be x to the power of 3 over 2 will be equal to 5 to the power of 3. Now to find the value of x, we can just, it was x to the power of 3 over 2. What we do, we will raise this side to the power of 2 over 3, the inverse of 3 over 2. So if we do that one side, we must also do the same on the other side to maintain the equation, to keep the equation same. Okay, and then doing so, 3 and 3 simplified, 2 and 2 simplified, and then we have left with x there, and then over here, also 3 and 3 we simplify, we'll have like 5 squared, and that makes x is equal to 25. Okay, that is question 4. Thank you. Then we can do question 5. Question 5, we have like x raised to the power of a half multiplied by 8x to the power of 1 over 4 plus 15 equals 0. Okay. So in this case, we can do some tricks here. We need to we will try to write the exponents here with a common denominator. Okay, so because it's a half there, it can be written as x to the power of 2 over 4. You know, 2 over 4 is just a half. Okay, minus 8x to the power of 1 over 4, and then plus 15. Then what we can do here is we can just make this x to the power of a quarter there to the power of 2. Okay, this is still x to the power of 2 over 4. You know, the law of exponents says a to the power of m raised to the power of n is just equal to a to the power of m times n. So 2 over 4 here is like a quarter times 2, okay? Like, let me write it here. X to the power of 2 over 4 is like x to the power of a quarter multiplied by 2, okay? And then this can be written as a quarter, x to the power of a quarter to the power of 2. So this is why I write it like this. And then we have like negative 8, excuse me, negative 8 x to the power of a quarter plus 15. The idea was like if I can have x to the power of a quarters, so then I can call it a certain variable like n. I can call it n. Let's say this is n, substituted by n. And then this is like having like n squared, okay, minus 8n plus 15. Now we have equals 0. Now we have a quadratic trinomial. We can solve this by factorization, okay? We do know that to do that, I'm going to look at the last term, 15, okay? And I list all the factors of 15. They are 1 and 15, and then 3 and 5. Now I ask myself which couple of the factors of 15, okay, can make a sum equal to the coefficient of the middle term, negative 8. You know, with 5 and 15, we cannot make negative 8, but with 3 and 5, yes, we can. If we have negative 3 and negative 5 there, okay, because negative 3 minus 5 makes negative 8. So we do negative 3, negative 5 there, all this equal to 0. Now this means that n minus 3 is 0, or n minus 5 is 0. That means that n equal to 3, or n equal to 5. Now, remember that initially, we're not calculating n, we were calculating for x. The question says solve for x. So xn, we substitute by x to the power of 1 over 4, okay? Or x to the power of 1 over 4 equal 5. But if I need to get the value of x, I'll raise this part to the power of 4 over 1 and do the same there also. And then raise this one to the power of 4 over 1. And then there also a 4 over 1. Why 4 over 1? Because 4 over 1, here this and this can be simplified, and then I can get x. X to the power of 1 just x. And then 3 to the power of 4 is 81. Or there also x, and then 5 to the power of 4 is 625. Okay. Yeah. That was question 5. Now we can also do question is from question 6. Question 6 was 2 to the power of 3x plus 2 plus 8 to the power of x plus 1 equal 48. Then we're going to write each term here, each number here in terms of prime factors. You know, 2 is already a prime number, so 2 to the power of 3x plus 2. I prefer to break it up into 2 to the power of 2 times 3, excuse me, 2 to the power of 2 times 2 to the power of 3x, okay? Remember that this low 8 to the power of m plus n is just 8 to the power of m m multiplied by 8 to the power of n, okay? So over here, we can break it up into two terms. I prefer to start with 2 to the power of 2 and then 2 to the power of 3x. Plus 8 can be written also in terms of its prime factors. So 48. So 8 in terms of prime factors is just, it's gonna be 3 times 2 to the power of 4, okay? If you're unsure, you can use a calculator. We can do, to do that, we can write 48, and then we press equal, okay? And then shift and then press the fact button. So that makes yes to the power 4 times 3. As I was saying, 3 times 2 to the power 4. Over here, 8 in terms of prime factor is just 2 to the power of 2 to the power of 3. Then this will make what? 2 to the power of 2 is just 4 times 2 to the power of 3x, plus over there also with times exponent, okay? It's like 2 to the power of 3x plus 3 equal to 3 times 2 to the power of 4. Then that makes 4 multiplied by 2 to the power of 3x plus 2 to the power of 3x multiplied by 2 to the power of 3 equal to 3 times 2 to the power of 4. And that makes 4 times 2 to the power of 3x plus 2 to the power of 3 is 8. 8 times 2 to the power of 3x equal to 3 times 2 to the power of 4. Now, we can call this just n, right? So this will be what? It's like 4n. If this is n, you have like 4n plus 8n, which means 12n. So I can write here 12 times 2 to the power of 3x equals to 3 times 2 to the power of 4. Or maybe let's just leave it 48 as it was, because 48 so far. Why am I doing that? Because I know I can divide here by 12 and then also by 12. And then I'm left with 2 to the power of 3x. 48 divided by 12 is just 4. And then 4 is 2 to the power of 2. Then what we do in this case, we can just drop the bases here and then equate the exponents. So that makes like 3 to the 3x equal to 2. And then we divide both sides by 3. That makes x is equal to 2 over 3. That is answers for question 6. And 6 is the last question here. Thank you.